This is a Java crash course to remind yourself of the most common Java instructions for your upcoming coding interview. So let's start with a quick introduction. Remember, Java is a statically typed programming language. Types have to be declared. It's a compiled language, so it provides faster execution than interpreted languages such as Python. It's strongly object-oriented. Everything is in classes, as you can also see by this main code. It's very popular for enterprise applications and for Android development, and it's essential for technical interviews at many companies. Let's look at the main instructions you're going to need during your interview. Let's start by looking at static typing and at variables. Static typing means that you have to declare the type of the variable. So in this case, if you want an integer variable, you have to put this word int. When you use int, you are declaring a native variable. Instead, if you don't want a native variable, you want an actual class, you can use the integer that is provided by Java. So you can have integer y equals to 5. So this is just another way of declaring int variables. Then for strings, where you can put any kind of string, so it doesn't have to be just characters, you can have numbers and special characters as well. For prices, you can use double, or even better, you can use something called the big decimal. So if there is anything related to amounts and prices or currency, you can just use big decimal. You can also have multiple assignments in the same line, and to do that you can use the following syntax, where you can separate each assignment by a comma, but you have to make sure that the variables have the same type. In this case, they're all 3 ints. Very important for coding interviews is incrementing and decrementing a variable. So in this case, we've got a count variable, which is of type int. You can increase its value by doing count plus plus, which is equal to doing count equals to count plus 1. So that's just a shorthand. Same for the minus. You can do count minus minus instead of doing count equals to count minus 1. And same for addition and product. You can do the same also for division. There are a lot of data types that come out of the box with Java. Let's talk about the primitive types. We've got 6 primitive types, such as int, that you can use to store whole numbers, and the precision is 32 bits. You've got long to store even longer int numbers. In this case, the precision is up to 64 bits. We've got doubles, where you can save decimal numbers. Float, which offers 32 bits. So double it doubles the precision up to 64 bits. We've got booleans for true or false. And character. Character is a single character, so it's only 1 byte. So we've also got reference types. Most of these also have object representation. What I mean with that is we've got the integer class, we've got the long class, we've got the double class, and etc. So in this case, the integer is also called a wrapper class around a primitive type int. The benefit is that you can take num object and you can apply all these methods, whilst the same is not true for the primitive type. As you can see, there are no methods that we can apply. And you might have also noticed that string is not a primitive type. It's actually an object. It's a class. One way to differentiate between primitives and non-primitives is that primitives, they have all lowercase at the beginning, whilst the reference types, they've got a capital letter at the beginning. Let's now look at some of the operations. So you got math operations such as integer division. In this case, you can see that the result is going to be true because both of these are ints. Then you got double division. To have double division, you have to make sure that one of the operand is actually either a float or a double, and then the destination variable also has to be either float or double. So in this case, you can see the result that this operation is going to give is 2.5. We've got the modulo operation, which is represented by this percentage symbol. We've also got power. To do power, we're going to be using the math library. and you can do 2 to the power of 3 in this way. So in this case, this is the base number and this is the power. We then got the comparisons. To do equality, you have to use the double equal, so you can't really write just equal, you need to have double equals. If you just put a single equal, you are doing an assignment, so this is not valid. So you need double equals. To do not equal, you have to add the exclamation mark. Then we've got some integer limits, so sometimes this might be useful. What this gives you is the maximum value that an integer can hold. So this is the maximum value that the int can hold at a single time. And you can do the same for the other numerical variables. So let's say you want the long maximum value, you can do long.max value, and you can do the same for double. We have various logical functions in Java, and these I would say are the ones that you're going to see the most in coding interviews. When you do AND, this applies the logical AND between two operands. So in this case, true and true is always going to be true, whilst true and false is going to return false. We've got the OR, so at least one of the operands has to be true. So in this case, we can see true or false returns true, and false or false returns false. We've also got not, so this one inverts whatever the value of the boolean. So in this case, not true is going to return false, and not false is going to return true. We then have bitwise operations. As you can see, this is the same AND that we use in the logical AND, but the difference is that when you want to do bitwise AND, you just put a single ampersand symbol. When you want to do a logical AND, you have to put it twice. So in this case, what this is going to do is going to convert each of the operands in binary, and then it's going to do a bitwise AND between them, and then it's going to return you the result. We can also have a bitwise OR, a bitwise XOR, bitwise NOT. You also have left shift. So what this does is it shifts all the bits in your operand by the amount you have indicated, which is the same as multiplying by 2 or dividing by 2 when you right shift. We've also got something called short circuit evaluation. So what this means is that when you've got this logical AND, and because for an AND to be true, both operands have to be true, if the first operand is false, we are not going to evaluate whatever is on the right, which in this case could be a very expensive function, which we only want to evaluate in certain occasions. So because of this short circuit evaluation property in Java, this is quite good and it increases the speed of your program. In Java, we've got different types of loops. So let's start with this first one. This is a typical for loop where we got 3 operations. So you got the starter value, in this case 0. You also have to make sure that to declare whatever type you want. Usually it's a counter, so it's usually an int, but you can have anything here. It can be a double, a float, or whatever you want. You want to have a stop condition, and then you want to increment as well, because if you never increment this I value, this is always going to be true, and you will end up with an infinite loop. And then inside the for loop, you've got the operations you want to perform. We got something called the enhanced loop as well. So let's say you got an array of integers and you want to iterate through each of these values, and you don't really care about the position, you just want to traverse this in whatever order the array is. To do that, you can use something called an enhanced for loop. So you just declare the type of the array you want to traverse. So in this case, an array of ints. You're gonna go through each int, and in this case, we're going to print it. This is also called a for each loop. So for each element of the array, you're going to do an operation. We can then move on to the while loop. So the syntax is quite simple. Whilst this condition is true, we want to do whatever operation is in the body. And you can see we also want some kind of incrementer because you want to stop at some point unless you want an infinite loop. We then want a do-while loop. So the difference between a while loop and a do-while loop is that the do-while loop is going to run at least once, because what happens is we first run this operation and then we evaluate if this is still true. If we go back to the for loop, there are few things we want to talk about. Those are the break and continue operation. So we've got the break keyword, which basically, when a condition is met, is just going to exit the loop. So let's say you are at k equals to 5. This is not going to continue if k becomes was continue. It's useful when you want to skip an iteration for a specific number. In this case, if k is 3, we just continue. So whatever is going to be written down here, whatever operation we're going to add after the continue, is not going to be executed for that specific iteration. Let's talk about streams. In Java, you got these operations called streams that you can apply to lists. So in this case, we can create a list from a range using an int stream. So in this case, we're going to create a list of integers that starts from 0 all the way to 9. So this second operand is excluded. And you can use this stream. And at the end, once that all is done, we use a collectors2.list to create this list of integers. We then got filter operations. These are also quite useful. We can stream whatever is in our numbers. So in this case is the list of integers we created earlier. We go through each of the values of the list, very similar to a for each. And we got a filter operation. So we want to filter out all these numbers. So in this case, it looks like we want to filter out even numbers. And then we save these even numbers to the list. Very similar, we've got maps. The map basically is going to take each number in the list of integers and it's going to square it. So at the end, we're going to have a list of squared numbers. We can see how having streams actually reduces the lines of code we have to write. And in the long term, this becomes easier to read. So instead of having a lot of if, else, and etc., just use these operations over here. Methods are very useful in organizing your code and keeping the structure very clean. In this case, we've got two methods. One is an add method and one is a sum. You can see that when you want to declare a method, you want to give the input variables, and then with those input variables you want to do something, and most of the cases you want to return a value. So when you want to return, you have to define the type of return up here in the method definition. Otherwise, if you don't want to return anything, you want this to be a void method. We then also got a method with something called var args. So in this case, we got these 3 dots, and this defines that this method is going to get as input any number of int variables. So in this case, we have a sum, and we want to sum all of the numbers that we send as input. This input variable kind of gets treated as a list, as you can see from this for each loop. We go through each number and we sum them together. So if you were to increase this by, I don't know, 6, 7, 8, whatever, this is still going to be handled by the same method. Sometimes during an interview, you might have to cast from one type to the other. And because Java is type safe, there are specific methods that you can use to do this conversion. So if you want to convert from string to int, you have to use the parseInt method inside the integer class. So if you look at it, this is a static method, which is part of the integer class. So you simply do integer.parseInt, and as input, you're going to pass the string. Then we can parse strings to double, very similarly to what we did with integers. We can use this static method provided by the double class called parseDouble. So we can convert integers to strings. So you can do string.value of 1, 2, 3. Or you can also use the toString method of integer. I believe double has a toString as well. Most of the data structures, they've got a toString method that is going to help you print out the data structure in a structured way for your standard output. Very similarly, there is another way to convert as well, which is called typecasting. So if you got a double, you can convert to int by adding these two brackets, put the target type you want, and the value. So in this case, this will be truncated because a double is going into an int. So we will also take the integer part, which is 3. So it will not apply any kind of rounding. So this is also very useful and it comes up during interviews. And that's the ability to convert a character into int, so into ASCII values. And you can do the same the other way around. You can convert an int to a character. Java is an object-oriented programming. Classes and objects are the bread and butter of this programming language. So in this case, you can see we define a new class called listNode. And to do that, you have to use this public class keywords to define a new class. In this case, this is going to be a child class of the main class. If you were to have this in a new file, you have to make sure that the class name is the same as the file name. And the class name has to start with a capital letter. We then got constructors. So constructors are the methods that are actually going to build the object that is being defined by the class. So you can think of the class as a blueprint and the object as an instance of this class. We got 2 constructors. And you can see that to instantiate an object using the listNode class, you have to use this keyword new, and then you have to pass the initial values. In this case, depending on the values you pass, Java is going to decide which of these 2 constructors to use. String is a crucial data type of the Java programming language. So a string is a collection of characters that are saved in this string object. And as I said, string is not a primitive type. So there are few methods that are quite crucial and that you need to know to pass your coding interview. So let's start by the length. So the length gives you the actual length of the string. Got the character at index. So let's say you want the character at a specific index. You can use this method and your string will be treated as kind of an array and you will be given back that specific character. You can also do substring. So substring is quite useful. You pass the starting index and the end index. Remember that the end is exclusive. So the fourth will not be counted, but it will stop at 3. We got string concatenation, so you can simply concatenate a string using the plus or using the concat method. They are both the same. You can also split a string based on a character using a regular expression. So in this case, using the split on the comma, we're going to create an array of strings. So in this case, this will be split into 3, A, B, and C. You can also join. Let's say you got a string which is ABC. You want to join these elements by a delimiter. You can use this method to put those together. So let's say you want this to be hashtag. The output will look like this. Contains returns you true if your string contains this substring that you pass as input. You can also replace a character. So the first is the old character and you can replace that with a new character. You can transform a string all to uppercase or to lowercase using these 2 methods. And there is also string comparison. So to check if 2 strings are the same, you have to use the equals method or the compare to. We also got string builder. So you have to remember that strings are immutables. So once a string is built, you can't really modify it unless you build a new one. What I mean is that when you do this, string equals to sub equals to ABC. This gets created in memory and there is a reference to this ABC. When you do this, sub equals to DEF. This one creates a new object and it assigns the reference to this sub. That's what it really means when we say strings are immutable. We've got string builder. A string builder is more efficient for concatenation in Java. So you can use this append method to append to a string builder and then you can just use the toString method to convert it to a string object. Let's talk about the array list data structure. So you can define an array list the following way. You just need to use the new and then you define an array list. You can also define an already initialized array list and you have to pass this into the constructor, a list of numbers. We have then the main methods that you can use on an array list. So you got add, that adds elements to the list. You can also add at specific indices. So in this case, at index 0, we want to add 0. And you can see this is the output when we initially had 1, 2. We can get an element at a specific index using get. You can set an element at a specific index using the set method. You can get the size that is going to return an int depending on the number of numbers we got in our array list. You can remove using this .remove by index. So when you do this, it is going to remove whatever index you have provided. You can also remove by value. So if you want to remove number 2s, you can just use this syntax. If you want the last element, just get the size and make sure you add -1 to avoid array out of index exceptions. If you want to check if a list contains an element, you can just use contains. If you want to find the index of an element, you can use index of, and if no element is found, it's just going to return you -1. You can clear an array list using a clear method. You can reverse it using the collections.reverse, and as input just pass your list. You can sort, so using the collections.sort, and you can also do it in ascending order by using collections.reverse order as input to this sort method. You can convert a list to an array using the toArray method, and you can convert an array to a list using the arrays.asList method. You can subtract a sublist. This math.min makes sure that you don't go out of bounds. So we can copy an array list by simply passing as input to the constructor the list that already exists and that we want to copy. Let's now talk about arrays. So to declare an array, you have to use this square brackets annotation next to the type of array you want. So we cannot have mixed arrays in Java. You cannot have two types. It's not like Python. In here you have to define the type of elements that are going to go in your array and then do new int. In this case you can define a size. In here we've got a size of 5 and it's going to create it with 0 as elements of the array. This is another way to initialize an array. So you can create an array doing R2. And then using the curly brackets, you can put the elements you want. You can have a matrix using this annotation. It's going to create a 2D array. This is the number of rows and this should be the number of columns. We've got length. Using the length variable, you're going to get the length of the array. We have the fill method that you can use from the arrays class. You can copy an array, again using the arrays class. We can sort an array. You can sort it by range. So what this means is that we just want to sort this array from index 0 to index 3. You can perform binary search on a sorted array using this method binary search. You can also convert an array to string using the .toString method. And you can also convert a 2D array to a string using this deep2.string. And you pass the matrix as input. Let's now move on to linked lists. So a linked list is another important data structure in Java. To add to a linked list, you can use various methods. We can have the add first. This is going to add the element to the front. You can also do offer first. If something already exists, you can just use this other method. If you click in it, it's going to tell you what happens. You can add to the back of the list, so you can do .add last or also offer last. To get the first or the last element, you can use these two methods, get first or get last. These are similar to the p methods inside the deck in Python. You can also remove the first and the last elements. You can get the size of your linked list using the .size method, and you can also check if the linked list is empty. Let's move on to HashMap. A HashMap is a crucial data structure for any coding interview. It helps us to come up with linear time complexity solutions. So let's have a look at it. To define a new HashMap, you can just use new HashMap, and you have to define the types of the key and the value. So in this case, the first operand is the key and the second one is the value. You can directly add to a HashMap using the put methods. You have to give a key and the value. To get a value, you have to pass the key for which you want the value to be returned. So in this case, if you do get A is going to return you 1 because that's the value we added earlier. We also have this other method called getOrDefault. In case there is no key found for the one we passed, we can return a default value using this annotation. You can also check if the HashMap contains a specific key or if it contains a specific value. You can remove from the HashMap by key. You can use the .remove, pass a key and get that entry removed from the HashMap. You can get the size of the HashMap as well. To iterate, there are different ways. So the first one is to iterate by key. You can get the key set, and because we define the keys as strings, we're going to use a for each to go through each key. And then using a get, we're going to get elements for each of those keys. The other way is to go by HashMap entry. So imagine the HashMap as a list of entries where you've got a value and a key. What I mean is something like key value 1, key value 2, and etc. So imagine it as a list. You can use a for each, get the whole entry of your HashMap using map.entry. You define the key and the value. And that way, when you're in your for loop, you can just do entry.getKey and entry.getValue. Sometimes you might need to get all keys, so there are different ways. One of them is to just use the integrated method called keySet. You can also get all the values. You can clear the whole HashMap using a .clear method. And to update a value, just use put. In Java, we've also got a data type called HashSet. So you can define it this way, where you have to give the type of elements that are going to be in the set. In this case, we define the hash set of integers. You can add using the add method, but you have to remember that in a set, we cannot have duplicates. So if you try to add a duplicate, this will not be added. You can check if a set contains a certain element using the contains method. You can remove an element from the set, and you can also iterate through a hash set. And to do that, you can use a for each, and using the set, we're going to go through each of these elements. You can convert a set to a list, and then you can maybe apply some ordering if you really want. If you've done coding interviews, you must have come across coding questions that needed a stack. In Java, we've got a data structure that is exactly doing that, and it's called stack. So you have to define the type of elements that are going to go on your stack. In this case, we're going to have a stack of integers. We are going to push onto the stack, and then you can pop, which basically is going to give you the last element you have added to your stack. So in this case, it should return 2. We can then also just peek, which means that we're going to get the first element of the stack without actually removing it. We can check if a stack is empty and get its size. We can think of a queue as the opposite of a stack. What this means is that the queue is going to return us the first element we have added to the queue, and we can represent this in Java using a linked list. So you can enqueue elements using queue.offer, and then you can remove from the queue using queue.poll. So this is going to return us the first element we have added. In this case, this is going to be 1. You can then also peek, so you can look at the first element that is going to be returned without actually removing it from the queue. And then you can do the empty checks and the size checks. These are the algorithms to the most common patterns we are going to see in coding interviews. So the first one is the 2 pointers, where you're going to have a left and a right pointer, and this is going to be used to traverse an array. You can pause the video and look at each of these. We've then got a sliding window where, as the name says, you're going to create a window of pointers and then you're going to slide this through an array or a list. We then have DFS, which is depth first search, and also breadth first search. So these are the most common patterns you are actually going to encounter during a coding interview. I hope you found this video useful. Please don't forget to like and subscribe.